In this video, you will learn how to solve for a missing variable in an angle pair relationship diagram by writing equations, solving for x, and plugging x back in to find the measure of the missing angle. The first thing you want to do is, looking at the diagram, determine what the relationship is between the angles that are shown. These relationships are all the ones that we have learned over the last few days. Then, once you determine the relationship, use the relationship and what you know to write and solve an equation to find the value of x. Finally, plug x back in to the expressions to find the angle measure in the diagram. Let's take a look at some examples. In this first example, the angles that are labeled 4x minus 6 degrees and 6x minus 20 degrees are what are called corresponding angles. We learned that corresponding angles are always congruent, which means they are equal to each other. So we can write an equation that shows that this angle is equal to this angle. The equation would look like this. 4x minus 6 is equal to 6x minus 20. Since we know they are equal to each other, when we solve this, this will tell us what the x value is, and then we can plug it back in to determine the measure of the angles in degrees. Remember, when we solve an equation with variables on opposite sides, we need to first combine both of the x terms onto one side. We're going to start by subtracting 4x from 4x, which gives us 0x, and then also subtract 4x from 6x, which gives us 2x. If I bring everything else down, the minus 6 is left alone on the left-hand side, equals 2x minus 20. From there, I'm going to add 20 to both sides because minus 20 and plus 20 will cancel out, and a negative 6 plus 20 is 14. Finally, since 2 times x is 14, we will divide 14 by 2 to get that x equals 7. Now that we know that the x value is 7, we have to still find the measure of each angle. So 7 is not the measure of the angle. 7 is just the value of the variable x. So we now can take this and plug it back in to the two expressions. 4x minus 6, which is 4 times x, and since x is 7, that's 4 times 7, which is 28, and 28 minus 6 is 22 degrees. 6 times x, which is 7, is 42, minus 20 is also 22 degrees, which makes sense because we said originally that corresponding angles should be congruent or equal. If you got two different answers for those two angle measures, one of two things could be true. One is an easier correction to fix, which would just be that you simplified this wrong. But the other possibility is that you either solved the equation wrong or your original equation to start was wrong. So there's a few different things you could check if your answers don't turn out to be equal when they should be equal. Let's try this example. In this diagram, we are trying to find the value of x in this expression 14x minus 16. These angles shown are what are called vertical angles, and as we recall, vertical angles are congruent as well, just like the corresponding angles we used in the last example. Since they're congruent, we know that they're equal to each other, and we can write the equation to show that. 14x minus 16 equals 124, and then to solve for x, I add 16, which gives us 14x equals 140, and then 14 times what number equals 140? I'll divide 140 by 14, which gives us that x equals 10. Now, in this case, the problem just asked us to find the value of x. We don't actually have to plug it back in, but if we want to make sure that we did the right problem, we solved the equation correctly, we can still check to make sure that I do get 124 degrees, which I do. So I know my equation is right, and I know my x value of 10 is correct also. Now let's try this example. The directions here say to find the measures of angles UTS, that's this one, and angle STV, that's this one over here. Now we can obviously tell by the diagram that these two angles are definitely not congruent. So we need to figure out another relationship that they share. One relationship that they share is that they are adjacent to each other, they are next to each other. However, just because two angles are next to each other isn't going to help us write an equation, because we need to know something about their angle measurements in order to write an equation. So yes, they are adjacent, but what do we know about their measurements? If they're not equal, what are they? Well, in this case, since we see that straight line across the bottom, UTV, we know that together, the 3Q and the 15Q plus 18, those two angles should add up to equal a straight line, which is 180 degrees. So that is what our equation will look like for this example, which is different from the first two examples that we've done. So our equation here is 3Q plus 15Q, which makes 18Q, plus 18 equals 180. We'll next subtract 18 from both sides, giving us that 18Q equals 162. And finally, we'll divide both sides by 18, which tells us that Q equals 9. But remember, the directions say we need to still find the angle measures, so we're not done yet. So let's start with UTS. We know angle UTS is 3Q. If Q is 9, 3 times 9 is 27 degrees. And for angle STV, that is 15 times Q, which is 9, plus 18. 15 times 9 is 135, and 135 plus 18 is 153. Now, we do not get the same answers, which we expected. We aren't looking for them to be equal. However, we are looking for them to equal 180. So just to make sure your answers are correct, you can take one extra step at the end, and that's just to check to see, does 27 plus 153 actually equal 180? Yes, it does. So that means our equation's correct, our value of Q is correct, and we evaluated the angle measures correctly as well. In this example, we have 2x degrees and x degrees shown in this diagram. The relationship here between the two angles, just like the last one, is adjacent, but again, adjacent doesn't give us enough information. So we also need to know that these two angles are complementary, which means they add up to equal 90 degrees. So this example is going to look a lot like the last example we just did, but we're going to add it up to 90 instead of 180. So here we have 2x plus x, which is 3x, equals 90. And this one is just a nice two-step problem here. 90 divided by 3 is that x equals 30. To find the measure of each angle, if this one is just x degrees, then we know that x degrees is 30 degrees because x was 30. 2x is going to be 2 times 30, which is 60 degrees, and we can see that 60 plus 30 does indeed equal 90. So we know we did it correctly. Take a moment to choose which equation would you use to find the value of y in this diagram. The expressions shown on these two angles are shown on angles that are alternate exterior angles. If you remember, alternate exterior angles are congruent or equal to each other, which means that option B would be the equation we would use. In this diagram, which equation would you use to find the value of P? Since these two expressions, 5p minus 3 and 7p plus 15, are shown on angles that are adjacent to each other and supplementary to each other, we know that they are going to add up to a total of 180 degrees because they form that straight line on the bottom, which means option A would be the equation we would use. Which equation could be used to find the value of x in this diagram? These two angle pairs are complementary to each other, which means they add up to 90 degrees. So option C would be our choice here.